all of its particles on the surface are observed receding radially. What do you mean by receding? Moving away from the center of the cloud with a velocity v naught. What will the radius of the cloud be when its expansion ceases? Initially, asteroid is at rest, it will expand. The question is like this. This O will be at rest, no? Asteroid of mass m explodes. So initially asteroid will be at rest. It will explode here. Then as it explodes, so what is this? I think cloud, no? Yeah. Again, you'll start. Relative angular velocity is what you have to take it. Herman, like what you're writing equations, no, there. Take help of relative angular velocity. I think, okay, fine. Yeah. Oh, okay, this is the is telling when radius of the cloud is r naught. The different point and that particular, they'll be moving with a velocity v. Okay, agree this. So this is what telling. Now, what is asking? What will the radius of the cloud be when its expansion ceases? V naught. Sorry. This is V naught. Spherically symmetric, but it will not occur spherically symmetric. We are to make our problem simple. I'm taking the spherical symmetric here. Now after this, I will. So this is a what the data given. Okay, let me assume there's a layer. So is it a disk or is it a sphere? Now anybody, is it a disk or a sphere? It's a sphere. Huh? I think the 3D diagram not possible. Now there's a layer I'm taking. Let me consider, no? So let this be radius r, small r. Let the velocity, speed of this be v. And this is r naught. So this, shall we call this as like a thin shell of radius r, thickness dr. So according to the given data, v naught by r naught equal to v by r. So what is v equal to? V naught by r naught by small r. He has not given much information. I'm just assuming some linear relationship. You may question this, sir, how you can say that one. He has not given anything, we'll go for linear. Or the speed of different layers, the speed of different layers will be different. So why can't all the layers will have same speed? So like I think that's very simplest. I took the point O will be attached. This layer moving. This point O, the midpoint of the cloud will be attached. Then this layer is moving with a speed v naught. Means what should happen to this speed? Should increase here, no? So therefore I'm taking the speed of any layer, let it be v. If he has further said anything about how the speed of different layers vary, some equation given, you could have chosen that equation. He has not said anything. We are going to take linear. You can take it for granted. Sir, in exam, you can take it for linear because nothing information available. Because one more thing, it was a test. This layer moving with speed V naught means you should go for linear. If it is not linear, you would have mentioned. Okay, don't scold me, sir, for sake of answer. You are assuming like this because that's the only condition available for me. Sir, it may vary exponentially. It may vary that one. Okay, I assume that you solve it, you will not get answer. What I assumed is it was reaching to the answer. I'm just defending myself. Okay, see, like I'm assuming linear that one, but it's need not. If I said anything how that variation occurs, you would have taken that one. Okay, fine. So don't scold me that, sir. Why only you took like this? It can happen anything. Let this be one of the possible situation. The speed of the layers. Okay, now what to do now? What he's asking. So what will the radius of the cloud be when its expansion ceases? What do you mean by expansion ceases? What should happen now? Finally, what happened the cloud? What should happen to cloud? All the points on a cloud should come to rest. That's what, no? Finally. Finally, all the points in the cloud should come to X. What was the mass? It was M. There's a cloud. Rest all particles. Expansion ceases. Is asking this X. This X is unknown. We have to find out here. Okay, I agree this. So I think this is a diagram. What we have, say initial. There's a final. Okay, how to bring the text from where to bring? So I am just taking help of the conservation of mechanical energy because there's the only thing is going to help us. So what all form here energy is available in the form of interaction potential energy or energy of the system, sorry, energy of the system, self energy of system, I'll write USI plus initial kinetic energy, final energy of the system plus final kinetic energy, and it is finally all particles are at rest. This will be zero. What is initial self energy? Minus 3 by 5 gm square. What is the radius of this r? No, can you remember yesterday's discussion? Plus what is the kinetic energy? This I don't know. I'm going to calculate. Ki. What is the final self energy? 3 by 5 gm square by r, and it is 0. Okay, fine. All particles are at rest. Okay, this is x. So what is our entire discussion now? The entire discussion is what to get that initial kinetic energy, no? How to bring that kinetic energy here? Different particles are having different speed. So first we'll calculate the kinetic energy of the layer of thin shell of radius r, thickness dr. The mass of this, let it be dm. So first kinetic energy of thin shell dk is equal to dm v square by 2. What is dm? Rho 4 pi r square dr by 2. What is v? V, I'll write it as v naught r naught small r whole square. Now proceed into the, we'll integrate. So what should be the value finally? Initial kinetic energy, this will be rho 4 pi 2 pi will come, no? So 2 pi rho v naught square r naught square r to power of 4 dr. 0 to capital R, you write it. Don't add 0 to x. For this diagram only, you're calculating it. Simplifying this, so we'll end up with 2 pi rho v naught square r naught square r naught, no? So r naught to the power of 5 by 5. Okay, that value substitute here and solve. So what is a rho? Rho, what you should write? M by 4 by 3 pi r naught cube. At that instant, substitute all this, you'll get initial kinetic energy and substitute also the rho here. Solve for x, you'll get the required answer. What is V? Speed of a layer of radius r. What is V naught? Speed of a layer of a radius r naught. I read on the answer. Go for calculation afterwards. 2gm r naught. Just the idea of self energy, but this is something, leave all this mathematics. This is something related to the universe expands, Big Bang occurred, how that explodes. Something what happened, they wanted to introduce students at this level, the idea of the Big Bang. The idea of the Big Bang, why universe expands, sir? Anybody asks? Yes, we have a suitable explanation here, no? And one fine day, what will happen? How that same dissolution of universe will occur? One fine day, what happen when all the particles of the cloud, if they come to rest, again due to mutual gravitational attractive force, the whole universe starts contracting. And one fine day, what happen? It will become a dot. Again, after some duration of time, again it explodes. Like that, what happen? This explosion, expansion, then coming to instantaneous rest, then contraction, then again becoming a dot. This is a cyclic process that is going on for billions of times. This is nature's phenomena is what the science is telling. Where is a God? Question of no God, no Allah, no Almighty, or no Bhagwan. The science is telling like this. But since I read scriptures, okay, as a physics teacher, I'll accept it. From where this asteroid has come, science is unable to answer. What made that asteroid to explode, science is unable to answer. So definitely in scriptures, there is some explanation is there. Okay, we have to go further. I think I don't have, or we don't have that much of spiritual power to really analyze to depth here. But as a physics teacher, yes, we can give some extent. So the scientific community, what is telling us, this is a nature's phenomena. So no question of God. So we know God. That's what they're telling. But how that, what makes it to explode, we don't know. So these are all some things are there. Just as a student, I think I must introduce to this also. It's a part of gravitation chapter because self energy has come. Okay, if you're interested, you can read Big Bang. So now you got idea. Universe is expanding. So think about this like a universe of mass m. The universe is expanding. So how it can expand, sir? Again, it contracts. How it contracts? Then dissolution. Dissolution means everything again will get contracted and again it will become a dot. So from dot, it will expand, will again finally come to instant rest. Again, it starts contracting. We are in expansion state. Then